Basic proportionality theorem or Thales theorem. This is the first theorem in the chapter Similar Triangles of 10th class. The statement of this theorem is a line drawn parallel to one side of the triangle divides other two sides in the same ratio. Let us understand this theorem by a diagram. This is a triangle ABC. The sides are AB, BC and CA. Now we will draw a parallel line to one of the sides BC in the triangle. This is a line parallel to one of the sides BC. Let us name it as DE. Now this DE line is parallel to BC. This parallel line will divide the other two sides of the triangle in the same ratio. That means AD by DB is equal to AE by EC. In the proof of a theorem, first of all, we have to write the given part of this theorem is in triangle ABC, DE is parallel to BC intersecting AB side at D and AC side at E. So this DE line is intersecting AB side at D, AC side at E. Now we have to write RTP. RTP means, you know students, required to prove. What is required to prove in the theorem? Yes, we need to prove that AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. To proceed further, we need to do a construction in this theorem. That is, we need to draw a perpendicular to AB side through E. Through the point E, we have to draw a perpendicular to AB. This is the perpendicular through E to the line segment AB. Let us mark F as this point. Also, we need to draw another perpendicular to AC side from this point D. Let us mark this point as G. Now see students, this EF is perpendicular to AB and DG is perpendicular to AC. Let us finish this part in the construction. Draw EF perpendicular to AB and DG perpendicular to AC. Also, we need to join the points BE and CD. Join BE and CD. Now let us move to the proof of this theorem. For that, you have to consider three triangles in this diagram. The first one is triangle ADE. Second one is triangle BDE. And the third triangle is CDE. The first triangle is ADE and the second triangle is BDE and the third triangle is CDE. Now we will compare the ratios of areas of these three triangles by taking two triangles at a time. First we will consider triangle ADE and triangle BDE. Area of triangle ADE by area of triangle BDE. Dear students, you know what is the area of a triangle. Area of triangle is equal to half of the product of its base and height. So if you consider the triangle ADE, its base is AD. AD I am taking as base. And what will be its height? Its height is EF. EF is its height. For the triangle ADE, ADE is base and EF is height. The same I am writing here. Half into product of its base AD into height EF divided by area of BDE. BDE, this is the triangle. For this triangle, we have to consider the base BDE and what will be the height. This is the most interesting thing, students, here. For the triangle BDE, if you consider the base as BD, height will be EF because this is an obtuse angle triangle and the height of the obtuse angle triangle will lie outside of the triangle. So this is the triangle BDE. If you draw a perpendicular from the vertex E to the base BD, it will fall outside of the triangle. So for this entire side AB, EF is the perpendicular from E. So for the triangle BD also, we have to consider as EF height. So what will be the area of this triangle BDE? Half into base is BD and height is F. What happens for this ratio, students? See here, half and half we can cancel and EF also can be cancelled. So it becomes AD by BD. This will be the equation number 1. This is the ratio of area of triangle ADE and area of triangle BDE. That is same as AD by BD. Now we will consider another pair of triangles here. I will take this triangle ADE and I am going to consider the triangle CDE. We will check the ratios of these areas. So here I am writing area of triangle ADE by area of triangle CDE is equal to. Now for the triangle ADE, I am going to take the side AE as the base. AE is base. If you consider AE as base, what will be its height? Its height is DG. DG will become height of the triangle. Understand? For this triangle, I am considering AE as base. DG will be the height of the triangle. So here we can write half into AE into DG divided by what is the area of triangle CDE? If you consider EC as base and height from the vertex D to the side EC will fall outside of the triangle like in the previous case. So DG will be considered as the height of the triangle CDE also. So here we have to write half into base ECE into height DG. Here also DG and DG can be cancelled, half and half can be cancelled, and this ratio becomes AE by EC. It will be the equation number 2. Now you see the triangles, dear students, triangle BDE and triangle CDE. These two triangles are lying on the same base DE and they are lying between the same parallel lines. You know this line DE is parallel to BC, no? Line DE is parallel to BC and these two triangles are lying between parallel lines and they are lying on the same base DE. So these two triangles, this triangle and this triangle areas will be equal because they are lying on the same base and they are lying between the same parallel lines. See here, triangle BDE and triangle CDE are on same base. What is the name of the base? DE is the common base and lying between parallel lines. What are the parallel lines? DE and BC. DE and BC. If the two triangles are lying on the same base and lying between the same parallel lines, then they are equal in area. So we can conclude here, area of triangle BDE is equal to area of triangle CDE. Area of triangle BDE is equal to area of triangle CDE. This will be the equation number 3. If you observe these three equations, here I took area of ADE by area of BDE. Here area of ADE by area of CDE. In the both ratios, area of ADE is common. Here in the denominator of the ratio I took area of BDE and here area of CDE. Now the area of BDE and area of CDE are equal. So these two ratios will be equal. From equation 1 and 2, we can write these two ratios are equal. AD by BD is equal to AE by EC. Hence, our theorem is proved. This is very important theorem in solving many problems in the exercise 8.1. So dear students, understand, in any triangle, if a line drawn parallel to one side of the triangle, it divides the other two sides in the same ratio. Here DE is parallel to BC. So AD by DB is equal to AE by EC. This is called basic proportionality theorem or Thales theorem.